Pilot Podcasts, where we break down complex topics into bite-sized pieces. Today we're diving into something that might sound a bit mathematical, but trust me, it's everywhere around us. Vectors and vector operations.
You know what's fascinating about vectors? They're basically these mathematical arrows that tell us both how much and which way. Like, imagine you're pushing a shopping cart. It's not just about how hard you push, but also which direction you're going.
Oh, that's actually a really good way to think about it.
Right, and there are different types of vectors. The simplest ones are what we call position vectors. They just tell you where something is relative to a starting point.
Like GPS coordinates?
Exactly. And you know what's really cool? Your phone's navigation system is constantly doing vector calculations to figure out where you are and which way you're heading.
Wait, really?
Yeah, it's using what we call velocity vectors, which combine your speed and direction, and acceleration vectors that track how quickly you're speeding up or slowing down.
So when I'm looking at my phone's map, it's basically doing vector math in real time?
Constantly. And it's not just simple addition, it's doing these operations like vector addition, multiplication, dot products, cross products.
Okay, hold on. Let's break those down, because that sounds like a lot of math terms being thrown around.
Right, sorry. Let's start with vector addition. Think of it like planning a hike. If you walk north for 3 miles, then east for 4 miles, the total distance and direction you've moved is a new vector.
Oh, that makes sense.
And multiplication is just like scaling that vector up or down, like if you walked twice as far in the same direction.
Right. But what about these dot products and cross products? They sound more complicated.
So the dot product is actually pretty neat. It tells you how much two vectors are pointing in the same direction. Game developers use this all the time.
Wait, what? In games?
Yeah, so in a first-person shooter, for example, they use dot products to figure out if you're actually aiming at a target. It's comparing the direction you're looking with the direction to the target.
That's actually really cool. I never thought about games using this kind of math.
And the physics engines in games, they're just full of vector operations, like calculating the bounce of a ball or the recoil of a weapon.
So what about cross products? What are those used for?
Cross products are really interesting because they give you a vector that's perpendicular to both original vectors. It's super important in 3D graphics and, robotics too.
Robotics?
Yeah, like when a robot arm needs to calculate how to rotate around a joint or figure out which way is up.
That's fascinating. It's like vectors are this hidden language that makes all our modern technology work.
Exactly, and you know what's really cool? Even nature uses vectors. Like birds calculating their migration paths, or bees communicating the location of flowers to their hive.
Wait, bees use vectors?
They do this amazing thing called the waggle dance, where they basically communicate vector information about where food is to other bees.
That's mind-blowing. So they're like little flying mathematicians.
Nature's been doing vector math way longer than we have.
Let's talk about some other types of vectors, because I know there are more than just position and velocity, right?
Oh yeah, there are force vectors, acceleration vectors, angular velocity vectors. Each one tells us something different about motion or force in the world.
Angular velocity, that sounds complicated.
It's actually pretty straightforward. It's just describing how something is rotating, like a spinning top.
Oh, right, because it's not just spinning at a certain speed, it's spinning in a specific direction.
Exactly, and that's what makes vectors so powerful. They can describe both the how much and the which way in a single mathematical object.
You mentioned force vectors earlier. How do those work?
Force vectors are really important in engineering. They help us understand, everything from bridge design to rocket launches.
Bridges?
Yeah, because a bridge has all these different forces acting on it. Gravity pulling down, wind pushing sideways, the weight of cars and trucks. Engineers need to understand how all these force vectors interact.
That's actually really important stuff.
And you know what's really interesting? When engineers are designing these structures, they often use what we call vector decomposition.
What's that?
It's like breaking down a diagonal force into its horizontal and vertical components. Makes it easier to analyze how the structure will handle different types of stress.
So it's like taking a complex problem and breaking it down into simpler pieces?
Exactly. And that's really one of the key things about vector operations. They give us tools to break down and understand complicated movements and forces.
You know what's interesting? We've been talking about all these practical applications, but vectors themselves are just this abstract math concept.
That's what's so beautiful about mathematics. These abstract concepts turn out to be perfect for describing the real world.
Like how video games use them?
Yeah, and you know what's really mind-blowing? Modern games are doing thousands of vector calculations every second, just to make things look and feel realistic.
Every second?
Think about it. Every movement, every collision, every particle effect, they all need vector math to work properly.
That's actually incredible when you think about it.
And it's not just games. Every time you use your phone's compass or GPS, it's doing vector calculations.
So vectors are really everywhere, aren't they?
They're one of those fundamental tools that help us understand and interact with the world around us.
And what's really interesting is how they connect different fields like physics, engineering, and computer graphics.
Right, and that's what makes them so powerful. They're this universal language for describing motion and force.
It's pretty amazing how something that seems so abstract can be so practical.
And we're finding new applications all the time, especially in fields like machine learning and artificial intelligence.
Oh, really?
Yeah, AI systems use vectors to represent and process information in really sophisticated ways. It's like they're thinking in vectors.
That's fascinating. We've really come a long way from just arrows on a graph, haven't we?
And yet those simple arrows are still at the heart of it all.
It's kind of beautiful when you think about it.
Mathematics often is when you really understand it.
Well, I think we've given our listeners a lot to think about.
And hopefully, next time they're playing a video game or using GPS, they'll think about all the vector math happening behind the scenes.
Or when they see a bee doing its waggle dance.
Nature's very own vector calculator.
And that brings us to the end of today's episode of Copilot Podcasts. Thanks for joining us on this journey through the world of vectors. Until next time, keep exploring the math in everything around you.